the director of the Hinsdale Wave Research Laboratory, and I'm going to show you a very brief introduction of what our lab is doing and has been done over the last years, particularly in natural hazards. It's not the only thing we do. We also do experiments on wave energy converters, marine energy approaches, floating offshore wind, and basically whatever you can imagine that goes into the water. I don't think I have to go tell you what is a natural hazard. Everybody is very aware, but the type of experiments that we do related to coastal natural hazard is a short list there. And you will see, and I'm going to be stressing on components that you might be interested, fundamentally tsunamis. So a little bit, a brief introduction on the facility. It was built in 1972. So we had our 50th anniversary a year ago, and well, since then, I don't see very well. We have two facilities, the large wave flume and the directional wave basin. They have different approaches, different sizes, different intentions, but fundamentally what we do there is testing of waves, and we are introducing new capabilities, including wind and possibility of currents. Since a little bit of story, and it's related to what you know, is in 2004, the facility was extended by National Science Foundations to be able to run tsunamis in the basin, and later on in 2008 also in the flume. And we were part of NIS until 2014. In 2016, we got the award of becoming part of the NEHERI program. We have been heard about the NEHERI program, and in 2021 we had the extension until 2025. Sideways, we also are part of the, we are collaborating with the Pacific Marine Energy Center. So we do, that's in the field of marine energy. And the Department of Energy also, we are part of them through the program TIMER. And I put there something that we are very proud of. We were last year the awardees of the Hamaguchi award from the PARI, the Port and Airport Research Institute in Japan, that is awarded to facilities that are being providing significant effort on coastal and tsunami research. So I'm going to show you very briefly some of the characteristics what we have, and then later on I will talk about a little bit of how you can access those. So on the large wave flume, we have two ways of generating waves. And we are also upcoming, hopefully the end of this year, a wind generation system, the directional wave basin, and other capabilities that are related to your work, including a new submersible force balance plate and ways of measuring underwater and above water motion. So, oh, it's great, it's working, the video. So this is ice view of the flume. So the flume is basically a narrow, long canal. Imagine if you make a slice of the ocean, and what you can do is to see the waves propagating in fundamentally 2dV, what we call. The type of experiments that you do there, the advantage is that they are relatively large scale. It's almost full scale in some cases, and from that perspective is the largest facility in the US. So this is the waves that we produce there are the largest ones, and we are top 10 in the world. So the dimensions are over there, but the important thing is that we have been using this facility since it was built in 1972. A little bit on the characteristics of the wave machine. We have two ones. This one is what we call the piston system. Is basically a wall of steel that moves back and forth, and that generates the waves. Is the one that has the capability of running tsunamis or very, very long waves. It's not a tsunami exactly, it's a tsunami-like wave, and we've been using it for a number of projects that I will highlight later on. What you see there is that's the performance curve, we call it. So every wave condition that you see in that curve are the waves that we can generate. So for a given water depth, everything that is under the curve is something that we can generate. So that is where that top element at the end is what what makes us the largest facility in the U.S. We recently also acquire another wave generation system, because the maximum water depth that we can achieve is with the other wave machine was limited to 9 feet. But we wanted to also to address some experiments for the marine energy industry, and fundamentally, and that's why we purchased a removable wave maker, because we didn't want to stop using the one that we have already. The advantage of this one is that can produce is compatible of running waves with current simultaneously, or sediment, for example, studies of sediment transport. So from that perspective is an additional asset, and help us to bring the wavemaker in different directions. This is a render of the wind generation system that is being built as we speak, and we are expecting to commission that in November. So we were going to be doing experiments with relatively high winds and waves as part of a study on the design of Nietzsche facility. I don't know if you have heard of it. It's a full-scale wind wave facility that National Science Foundation is supporting. This is the basin. Imagine an Olympic swimming pool. So what we are doing is releasing the three-dimensionalities of the modeling. So we can install there not only three-dimensional models, but also we can run the three-dimensional waves. Because the size of the facility has been increased in another direction, the size of the waves and the water depths that we can produce are about 50% of what we do in the basin. But this is just, for example, the render there you see on the right-hand side is an image of an experiment that we did through National Science Foundation on waves, tsunamis, and currents, and that we did a study on tsunami, transport of debris, and propagation in a coastal community. So the ability of the facility is that you can really think it as an open box, and then we build things on top of it based on the specific needs of the project. More recently, we purchased a force balance plate. It was a continuous question on wave structure interaction. Your structure, you want to measure what are the forces and the moments, and those are subject to the actual, normally those forces need to be measured on the water, and there is no specific instrument made for that. So we talked with a series of companies, and we found one instrumentation company that was able to build a submersible force balance plate for those experiments. You see the capacities there, and this is one of the examples that was placed recently. As we speak, we are doing it for a DARPA project, for example, on measuring the forces of the waves on a submerged reef. So what you see there is it's a study that we did early this year with the University of Hawaii on waterborne debris that was damming on a coastal structure. And we were measuring the forces of the impact of those debris pieces underneath that plate that you see there on the different columns. There is the force balance plate, and we have the 6 degrees of freedom and the motion of the forces there. We have another system that is now is getting advanced. Is Qualisys, is motion tracking system that has ability to measure motions above water and below water. The interesting thing is basically is measuring things without touching, which is one of the paradox of measuring. To measure something, you need to touch, and then you are affecting your motions or your measurements. So this is using infrared light or blue light if it's underwater to measure displacement up to submillimetric capacity. So depending on how close are the cameras. Recently, for example, trying to find different applications. Normally we use it for floating bodies, but we were measuring the formations of mangrove mimics in the flume, and the cameras were able to correlate the displacement with the hydrodynamic forces, and we didn't have to touch out of those 240 mangroves that we placed in the flume. This is going to be a quick list of different experiments that we have done through specifically National Science Foundation Haiti program since 2016. But I have to say that since 1972, you can imagine we have done experiments of all of them. Everything that goes into the water has been tested in the flume probably, including people, in surfers. And probably we have done in the last 50 years about 200 different experiments of all kinds. But these are related to tsunamis and structures, so something that could be out of your interest. Starting with the wave interactions with elevated buildings like houses, is also the effects of sheltering of islands, conical islands on the coast, the effect of what is called macro roughness and propagation of tsunamis, water tanks, so fuel tanks placed in different locations, deployable walls for protecting the flood, an additional study on islands, conical islands. The experiments of that cylinder that you see there is actually the foundation of a fixed wind turbine. Studies of specifically how the currents, the wind current, the wave currents and rip currents happens in the coast, generation of long waves and snake waves. I don't know if you have heard of those, but that's an interesting story of things that kill people on the coast every year. Submarine volcanoes, propagation on coast, as I mentioned, we have placed 1,000 cubic meters of sand inside of the flume for measuring the formations and how the vegetation of a dune is protecting or increasing the stability of a coastal profile. Elevated evacuation structures. That we did a series of experiments also for the University of Washington recently. The mangroves, full-scale mangroves that we tested first. Waterborne debris is the one that you see there at the bottom. Other things like nature-based solutions now is there's a lot of people working on nature-based solutions and engineering with nature, including, for example, the mangroves, but also those floating pods that you see there. Is a design from an architect in Boston. They are building that for Boston Harbor to protect the coast of Boston Harbor, creating a natural area. And we were studying how those elements were dissipating energy. A study with BARP systems, which is around here about harbor simulation on bridges and fixed marine energy components. Development of instrumentation, as I mentioned, the debris element, the new reduced scale mangrove studies, and so on. So anyway, there is a large amount of experiments that we have done in all kinds of spaces that you might be interested. Since we are part of Haiti and NSF, if you have a natural hazards, it's gone. So you have a National Science Foundation natural hazard related award. You can perform experiments at our facilities for free because the operational costs are covered by an NSF. The specimen costs are not included, but the major part, which is the testing, is included. And as others have been mentioned, the secret here is talk to us from the very beginning so we can have a nice and a correct design of the experiments and understand your needs and your research so we can give you the best successful program research. And with that, I am open to questions for later. Thank you.